Welcome to our video tutorials on VG software. In this video, we will show you how you can easily use VGTRAINER to train a deep neural network on a set of readily labeled volumes for segmentation. But first, let's have a look at the entire workflow. The most crucial element in training a deep neural network for semantic segmentation is the availability of a consistently and accurately labeled dataset. This dataset must encompass all potential scenarios that may arise during its application in a production environment. The model can only detect information based on the data it was trained on. Consequently, any unseen data will not be recognized or processed effectively. To label the data accordingly, you can use any segmentation tool available in VG Studio Max. Once you have labeled a sufficiently large set of volumes, you can start training a model in VGTRAINER. This is what we will focus on in this video. Finally, you can automate your entire inspection workflow, that is segmentation, using the trained model plus any analyses you have to carry out on your parts to use it at-line or inline on tens to hundreds of parts per day with VGinline. Now, let's directly dive into VGTRAINER. VGTRAINER will open on the Project page, where you can create a new project. If you already have a project, you can load it by clicking Open Project and locating the corresponding project description file. Or you pick a recently used project here to reopen it. The path of the current project will be shown here. Now let's create a new project. As VGTRAINER will organize all its files on your hard drive by itself, you simply have to pick an existing empty directory where the project data shall be stored. The name of the project description file will be vgtrainer.vgtp for all projects and cannot be changed. Once the project has been created or opened, VGTRAINER will directly jump to the next page, the datasets page. Here, you can basically specify the labeled volumes you want to use for training your model. One word about the term dataset. In the field of machine learning, dataset refers to a collection of several CT scans or volumes and not to a single volume. It is recommended that you create a top-level directory for the dataset and a subdirectory for each CT scan that is part of your dataset. So, back on the datasets page, I'll create a new dataset by clicking Add. Here, I'll select the top-level directory of the dataset I exported all the labeled data to. VGTRAINER will add all volumes for which it finds a labeled _volumes.json file to the list of training volumes of this new dataset. VGTRAINER will recursively search the selected directory and all its subdirectories for this file. You can create multiple datasets for a project and switch between them via the dataset drop-down list. If you want to remove a dataset from your project, select it and click Remove. This will not delete the data from your hard drive, but simply remove the dataset from the project. If you want to change the directory after having created the dataset, for example because you selected a subdirectory instead of the parent directory, you can click the Browse button. Next, I will remove all volumes I want to use for validation from the training column and add them to the validation column. A validation set is important because we need to make sure the model learns how to segment the data and not just overfits to the training set. That is, memorizes the training data. The only way to do this is by running the model on unseen data and comparing the results to some kind of ground truth. To move volumes from the training to the validation column, I can highlight one or more training volumes and click the right arrow button. Alternatively, I can click this button here to have VGTRAINER do the training validation split. This will apply a default training validation ratio of 80-20. For large datasets, it mostly does not matter if you have 10, 20, or more volumes in your validation list. As long as they cover all critical features of your dataset, 10 or less are enough. That way, you can have more of the valuable labeled data for training. Now you might ask, what is this unused column for? When I am not content with the labeling in a certain volume and I fear it might deteriorate the training, I can exclude this volume from both training and validation by moving it to the unused column. Next, I'll have a look at the Labels section, which lists all labels that were found in the selected dataset. Here I can verify that all labels are correct. If in our example, there were two hazelnut labels, one spelled with a capital H and one lowercase, they would be treated as separate classes and confuse the model during training. So, now I had the chance to get back to my data and correct the typo. Now, you see those checkboxes in front of the labels. If I were just interested in training the model on the hazelnut, I could uncheck the other classes so they would be treated as background. But be careful, don't use this option to exclude misspelled classes from the training, because treating the misspelled class as background would also confuse the training. Well, in our example, all labels are spelled properly, and I also want to train on all three classes. With this well-curated training and validation set, I can move on to the Run page, where I can configure the training. First, I'll select the dataset I would like to train on. That is the dataset I've just configured on the Datasets page. As this is the only dataset available, it is already preselected. Next, I'll click the Browse button to select a preset that defines the training parameters. VGTRAINER comes with a default preset, which works in most of the cases. Besides other training parameters, the preset includes the number of iterations. The default is 50,000 because it takes time to stabilize the weights of the model and to get the hard parts of the segmentation right. However, if you have a simple task for the model, or if you would like to test if the training works at all, 5,000 or 10,000 iterations may already be enough. Therefore, you can override the number of training iterations. Okay, that's all for the training configuration, and I can move on to the model metadata. I'll have to enter a name for the model, which will also be the file name of the trained model and displayed in the Deep Segmentation dialog in VG Studio Max. So I will name it Toffee Segmentation Net. And optionally, I can enter a version number, let's say 1.0. And a description, like segments the toffees into caramel, hazelnut, and toffee. Finally, I am good to go and can hit the Train button. Depending on how many iterations you've chosen, training can take up to a day or two. So, see you tomorrow. No, just kidding. In the meantime, we can have a look at the progress of the training. Besides the overall progress and a short information about the current stage, the training dialog will provide us with additional information about the training stage. VGTRAINER will report the progression of training and validation loss. That is the error the model makes on the training or validation samples, respectively, compared to the ground truth. Additionally, VGTRAINER will show images of the current segmentation results on the validation samples as soon as the first results show up. By default, you will see the center slice of each validation block, which can be changed using the slider to the left of the image. The validation images are colored in accordance with the prediction of the model. Each color corresponds to a class in the dataset. Correctly classified voxels, those where prediction and ground truth match, will be displayed opaquely, while misclassified voxels will be displayed in transparent colors. The images will always show the results of the validation in the current iteration. If you would like to see older results and inspect how the prediction evolved, you can drag the pole at the right edge of the loss plot to different positions, and the images will show the state of the training at that iteration. In the beginning, you will observe a lot of change both in the validation images and in the loss curves. Soon the output will stabilize. The observable change will become less significant, and after a few thousand iterations, you will already get a quite decent segmentation. Only then will the process of hardening those results slowly begin, and the training will converge towards a local minimum of the loss curve. It might happen that the model you are training will somewhat overfit to the training data and perform poorly on unseen data. During training, you can recognize such behavior when the training loss keeps decreasing, while the validation loss starts increasing again. This is another important argument for having a validation set. If overfitting occurs, you can mitigate the effects, for example, by adding more training data. The progress dialog allows you to abort and to stop the training. If you abort the training, it will stop immediately and no results will be saved. That is, all progress will be lost. If you stop the training stage will finish after the current iteration and jump to the validation stage. The trained model will be saved. This comes in handy when you are in an experimentation phase and consider the model good enough for the next step. After training, you can inspect each training run on the results page. You can select different training runs via the result drop-down list. Besides the name of the run, you will see the overall intersection over union, IOU, next to it. This will give you a quick notion of how well the trained model performs. The evaluation metrics used in VGTRAINER are all voxel-based and computed from 4 basic values: true positives, correctly classified voxels, prediction and ground truth match. True negatives, voxels are correctly predicted as background. False positives or type 1 errors, the model said the voxel belongs to a given class, but the ground truth says it is actually background. And false negatives or type 2 errors, the model said the voxel belongs to the background, but the ground truth says it belongs to a given class. The IOU, for example, is computed as the true positives divided by the sum of true positives, false positives, and false negatives. We use the IOU as metric because it does not take true negatives, that is, correctly segmented background, into account. In a CT scan, most of the voxels typically belong to the background. If we would simply use the accuracy as metric, a model that segments everything as background would achieve an accuracy of 90% or more. With the IOU being more sensitive in that regard, it is important to note that even slight deviations from the ground truth heavily decrease the IOU, and a model with an IOU of 0.8 might already do well during production. When you click Open next to the Output field, you will be redirected to the output directory of the selected training run. Here, you can find the trained model, which you can then import in VG Studio Max for deep segmentation. Next to the model file, you can find a more detailed final report. This report contains further information about the training data and how it was normalized, and a more detailed evaluation of the trained model. In case of a customer support request, please always send us this report file in addition to the usual log files. I hope you enjoyed this tutorial. For additional information on VGTRAINER, take a look at the Help page where you will find the reference manual and an introductory tutorial. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts. And stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.